Categorical scales are probably the most complicated ones because here you want to represent individual elements that do not have a specific implied order among them. So your color scale should reflect that there is no color that is more or less than the other. That means that you want to find a color palette where each color, where colors are perceptually different. So any pair of color is perceptually different. As in this example, where we see different activities of people during the day, we can see and clearly distinguish the red from the yellow, from the cyan, from the green, and we don't see any implied order between these activities. It's just different activities over the day. Now this works well for maps as well. For pole maps, we see this a lot where we have different parties being represented by different colors, and we can see which parts of the country have been voting for which party. Again, we don't see any order between these parties because they're individual units. In this example, however, it's a combination of a categorical color scales, the parties, and a sequential color scale, the percentage of people who voted for this party. So we can in the map see dark black areas, light black areas, the gray ones, and the same for the dark red and the light red and the green and the blue. Now, in choosing colors that are perceptually different, that make up your palette, such as in this case black, green, red, and blue, there are different ways, there are different tools. You can go online, you find loads of different tools that create your color palettes. One of them is I Want You, where you can specify a range of hues that you want your hues to lie in, a range for the saturation and a range for the lightness of these colors. And then if you click the magic button, it will cluster you these colors into as many colors as you want, perceptually distant. Now another tool that is more specific to data visualization is the Vis palette, where you can import a palette. We see this palette here on the left side, and it applies it directly to some common data visualizations. So you can see how this palette plays out in your specific data visualization that you're choosing, your scatter plot, in your tree map, or in your network. Are you happy with these colors? Do you think you need more difference? And so on. Now, of course, this example is not showing a categorical color scale. This would be a sort of sequential color scales that we see here. And to be more precise, it's a multi-hue color scale. This palette is a nice tool because you can also see how your visualization plays out in black and white. Your color scale, is it still discriminative? Can you still see the differences of all these colors in your scatter plot? Or maybe you want to go for another visual variable than dots. The same applies for lines here, which is kind of hard to perceive. However, it works when you have a bit more color to show in your visualization. This palette also can simulate how your color palette plays out in people with color perception deficiency. This is a chapter we're going to look into separately. Now, there's one more thing to know about how to choose colors, because our language tells us a lot of how we perceive colors, how we understand color. If you look across languages, most languages have terms for white, gray, and black. Now, white, gray, and black are not the type of color we're looking into as a visual variable. In data visualization, we know that white, gray, and black are actually luminance, which is a different visual variable from hue. However, again, if you look across languages, most languages have names for red, yellow, green, and blue, which means that these are very important colors that everyone agrees on. Only after these colors come second important colors are pink, brown, orange, and purple. And only then come colors such as cyan, magenta, rosé, and all these exotic ones. And if you choose colors, keep one more thing in mind, is what data you're representing. Sometimes it happens that there is a mapping, there is an implicit understanding of how you want your data elements to be colored. If I'm coloring fruits, I want my apples to be green and my bananas to be yellow and blueberries to be blue, not the other way around. That would be confusing. So if you choose semantically resonant colors for your data element on your legend, that helps people keeping your legend in mind, understanding your legend, and then reading the visualization according to these colors. What is true for fruits also holds true for other types of data sets, such as brands. If you're representing Apple, gray, AT&T, use something blue, and Starbucks, most people who know Starbucks know that this is green.